Now, first up, we're going to hear from a couple of those outstanding women who work here at the University of New South Wales and dig a bit deeper as we hear about their stories. First up this morning is Professor Angela Moles from the University of New South Wales School of Biological, Earth and Environmental Sciences, BEES. Now, Angela is a leading plant ecologist and heads up the Big Ecology Lab at the school. In 2013, she was awarded the prestigious Prime Minister's Prize for Science, the Frank Fenner Prize for Life Scientist of the Year. Now, she has won many other awards, including a New South Wales Science and Engineering Award for Excellence in Biological Sciences in 2012, and of course, an Australian Museum Eureka Prize, very coveted. We're presenting those at the end of this month, 26th of August. The new prizes will be presented. She won Outstanding Young Researcher in the Eureka Prizes in 2011. Now, Angela encourages female high school students into science by participating in the CSIRO's Science in Schools program, and she is also a jury member for the L'Oreal Women in Science Fellowship Scheme. Please welcome to the stage Professor Angela Moles.
Wow, thank you everybody. I'm now aspiring to be the mediocre middle-aged researcher. But I do love my job, I absolutely do. I'm so lucky I get to study beautiful plants. And in particular, what I do is I study the different ways that plants grow, reproduce, and interact with other organisms all over the world. And I'm just going to tell you about one of my research projects today, but it's a big one. It was called the World Herbivory Project. Now, I know I just used a jargon word there. Don't worry, herbivory is just when plants get eaten, either by big furry things like this giraffe here, or by little furry things like this wonderful punk caterpillar that I found in Peru. Now, before I started this project, scientists reckon they had this whole area kind of sorted out. We were pretty sure that plants were eaten more in the tropics, and because they get eaten more, they would have been under selective pressure to evolve higher levels of defences. But the thing is, nobody had ever actually tested this idea. So I decided to go out and test it. And what I did was I set up study sites in 75 really different ecosystems all around the world. And I actually travelled for 2 years solid, visiting all these sites in person, but I didn't do it on my own. I collaborated with basically every other ecologist in the world. It was just fantastic because I'd get out there in each site and I'd have the local experts telling me about all the amazing things that I was looking at. So it was absolutely stunning. I'll just show you some of my favourite study sites. My northernmost site was Zackenberg, the Danish Polar Research Station, and that was just spectacular because you go there and you feel like you've gone back to the Pleistocene. There's these big glacially carved valleys, big hairy muskox wandering around. You have to carry a gun for the polar bears. Absolutely spectacular stuff. The vegetation doesn't look like much from a distance. You really have to lie on your stomach to appreciate it, but I did. Those are my fingers for scale. And you can see here, this is the canopy species. It's an Arctic willow, and it is reproductively mature. In fact, it's probably 100 years old. So absolutely spectacular little ecosystems that only have their leaves above the snow for about 6 weeks of every year. One of my other favourite ecosystems was very different. It was rainforest in the Congo. This is just stunning, stunning rainforest. It's full of amazing things like gorillas and elephants and things. In fact, elephants made this ecosystem here that you're looking at, which is a bai, which is a clearing in the rainforest that's been caused by the elephants just pushing over all of the trees. So you get this grassy area in the middle of the dense rainforest that's full of all these splintered bits of trees and great big footprints from the elephants. Absolutely amazing. And the people there were amazing too. The average lifespan at the time I was there was 37 years, which is fairly sobering. My southernmost site was in Patagonia. This is a gorgeous Nothofagus forest. It was springtime, but it was a little colder than I expected. Just for contrast, this is a site in tropical forest in Panama. Everyone always looks at this and goes, oh wow, monkeys, but they sit in the trees and they throw these really big hard fruits at you, so they're actually a real pain. It's also weird because you'll be sitting there in the jungle, just minding your own business, studying a leaf. You look up and you notice there's a giant cruise liner going past because this island is in the middle of the Panama Canal. Everyone always thinks of rainforests when they think of the tropics, but actually there's a lot of the tropics where the rainfall is very seasonal. And these places you either get savanna or tropical dry forest. This is a tropical forest and it's deciduous. It drops its leaves not when it gets cold, but when it gets too dry. I did study savannas too. This is one in Shishlui National Park in South Africa. This is not a disaster in my own project. I was actually helping someone else out. My job here was to sit up in this tree and measure how quickly the fire was moving across the landscape. And I took the picture basically after I got too scared, decided to climb out and run away. I also went to some desert sites, so the beautiful Sonoran Desert with those lovely saguaro cacti. They actually concertina in and out as they take up rain and then use it up during the dry season. Just magic. And of course I included a whole lot of Australian sites because Australia's ecosystems are just absolutely fantastic. So it was a lot of travelling, but it wasn't just travelling. I actually gathered an awful lot of information about how much the leaves were getting eaten and how well chemically and physically defended they were. And in addition to actually going everywhere and measuring stuff, I did a big compilation of all of the available data from the literature. And gratifyingly, I got the same answer both ways, which wasn't guaranteed to happen. Now remember that we were really quite sure that there was going to be more herbivory in the tropics. Well, I found no latitudinal gradient herbivory. It turns out plants are eaten a lot by animals wherever in the world they grow. And we were also pretty sure that because they were getting eaten more in the tropics, they were going to be defended more there, and that was wrong too. In fact, the best defended plants are at really high latitudes. And I think that's probably because, remember I said those willows only have their leaves above the snow for 6 weeks of a year. Once you've managed to grow a leaf there, you've really got to do what you can to hang on to it because it's pretty hard to grow another one. So all of our traditional thinking in this big area turned out to be totally wrong. And this has got a few implications. One of them is for our understanding of global patterns in biodiversity. We know there are way more species in the tropics. Unfortunately, all of our current ideas about why this is rely on the idea that interactions between plants and animals and other taxa are more intense there. And that's not true for any of the above ground interactions that we've looked at so far. So I'm just starting to look at below ground. The other thing it's got implications for is bioprospecting. Whenever the pharmaceutical companies have been looking for a new amazing bioactive compound that might cure cancer or something, they've known that they should send their poor researchers in their lab suits into the rainforest. Poor guy. It turns out they might have actually done better to send him up to the Arctic. Okay, I only have one tip for success, and that is if you want to be a fantastic scientist, really you need to be much more like a 4-year-old. You know, that amazing sense of wonder they have. They look around the world and they go, why? Why is it like that? And you need to do that every day. You need to question everything you're looking at. And I think one of the things in science is a lot of our big old theories come from the 60s and 70s. And back then we didn't have much data. Our computers were just in their infancy. So a lot of the big ideas that we have in lots of fields have actually never been put through an appropriate test. And when we are testing them, we're finding that a lot of the foundations are actually a bit shaky. So that's a really important thing for people to do. Just finally, a couple of thoughts on women in science. And I'd have to say, I did not appreciate the magnitude of this problem until I had kids. The degree of gender stereotyping that's entrenched in the children I see around by the time they're like 4 years old is just shocking. And the degree of equality in parental duties is equally shocking. So a couple of things, not in my house, a couple of things that I think we can do about this. The first is outreach. The CSIRO Scientists and Mathematicians in Schools scheme is just brilliant. And we had so much fun figuring out with the Year 7s how to keep your Christmas tree alive the best. Yes, Brad. I wouldn't have thought of that treatment, they did. I actually think we need to do scientists and mathematicians in preschools as well to get them before it's too late. Second thing is, if we are going to strive for equality, we can't just focus on the women. We've got loads of really good initiatives going on in terms of how we can look after women in science, but we're never actually going to get into equality unless we can go through a bit of a cultural shift in terms of fathers' roles. And I think there are things that UNSW can do about that. For instance, if you look at our provisions for parental leave, the mother gets quite a good deal. The dad gets 10 days to give sort of a manly handshake and then depart back to work. Perhaps we could do better. Thank you.